Today's session is about number system in the topics related to mathematics grade 9 CBSE syllabus. So let's see what number system deals with. Many a times in mathematics we have dealt with different types of numbers, the number line. So these types of numbers which are dealt, like the decimals, like the fractions, or the numbers in the power form, have got different types of classifications in mathematics, which we are going to discuss in brief in today's session of number system. So let's see the different types of numbers classified in the branch of mathematics. Coming with natural numbers. What are natural numbers? Natural numbers are the numbers which cannot be expressed in fraction form other than the denominator being 1. Say for example, I take the natural numbers to be starting from 1, 2, 3, 4, 5, so on and so forth. The reason being that it cannot be expressed in a fraction form but can be expressed on the whole with denominator as 1. Say for example, I can write this as 1 by 1 and this as 2 by 1, this as 3 by 1 and etc. So natural numbers cannot be expressed in fraction form other than with denominator being 1. And the numbers which are positive and start with 1. So 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth till infinity are called natural numbers. And usually the natural numbers are denoted by capital N. Capital N equals 1, 2, 3, 4, 5, 6 is the set of natural numbers. We write this as set of natural numbers denoted by capital letter N is what we call natural numbers in mathematics. Let's see how we can deal with different examples and understand natural numbers more better. Let's try with different types of examples. For example, I would like to test if the number 5.9 is a natural number. So my question is 5.9 a natural number? Now let's see the answer for this question using the basic definition as we have learnt in the previous session of natural numbers. Now 5.9, if I take this right down here, I understand that it is a decimal number to the approximation of one decimal place, and this in turn can be written in the non-decimal form as 59 over 10. So 5.9 indirectly can be written as 59 over 10, which breaks the rule of a natural number because the natural numbers accept only the denominator as 1. Other than 1, any other number we take cannot be accepted in natural number. Therefore, this not being equal to 1 is not a natural number, strictly by the definition as we have learnt. So 5.9 is not a natural number, and I write this as 5.9 does not belong to the set of natural numbers, is how we understand identifying a natural number or not a natural number. Let's see many other examples to understand the concept more better. Now let's see the other types of examples to understand the natural numbers more better. For example, my next question out here is root 9 a natural number? Now the question here is all the numericals which are expressed in the form of roots cannot be a natural number because it is not directly in the numerical form, is point number 1, which I identify in the stage 1 of this being a natural number. Secondly, let's see if I can further simplify this to get a more simplified answer. We clearly know that 9 is a perfect square, so that root 9 we all know is equal to 3. Root 4 is 2, root 16 is 4, root 25 is 5, and hence root 9 is 3. Now, because this can be indirectly expressed in the form 3, we understand that root 9 is equal to 3, and clearly 3 is a natural number. And therefore, indirectly root 9, which can be expressed as equal to 3 after its simplified form, is a natural number, belongs to n, is how I understand the unsimplified questions given to be identified to be a natural number or not a natural number. So what do we understand from this basic example is that whenever a question is given about testing on a natural number or not a natural number, we try to simplify it to the most simplified form. It is very important to note that until and unless a given problem is simplified to the most simplified form, we cannot judge on the number being a natural number or not a natural number. Let's do one more example. Is 5 cube a natural number? This is my question. Yes, let's see. Or let me add this to it. Now, is 5 cube by 25 a natural number? So the first thing what I do is I try to reduce this to the most simplified form, and then I get to identify on the final justification of whether this number is a natural number or not a natural number. So let me take the given problem 5 cube by 25, and let me try to simplify this more further and then justify on this natural number concept. Now we know that 5 cube is 5 times 5 times 5, and 25 can be written as 5 times 5, and then the two 5's get cancelled out here. Then finally I am left with only one number, which is 5. And that clearly makes me understand that the given question 5 cube by 25 is nothing but indirectly the simplified form of 5. And then this we all know belongs to natural number. Therefore, 5 cube by 25 is a natural number, is how we justify through the most simplified form and then justification through that. Next, let's go with another example to understand the natural numbers more better. Now the question here is root 49 plus root 4 by root 9 a natural number? So here we see that there is more part of which to be simplified before we justify on this given number being a natural number or not a natural number. So the given question being root 49 plus root 4 by root 9 is to be further simplified, as we clearly know that root 49 is 7 and root 4 is 2 and root 9 is 3. I reduce them into the non-root form by using the perfect square number concept. And using this, I clearly understand that 7 plus 2 can be added further to get 9, and the denominator is 3. So that this can be further simplified, as we know that denominator and the numerator get cancelled for 3 times in the numerator. So 3 1s, 3 3s. My final answer is 3 for the given problem. So the most simplified answer for this is 3, and which is clearly a natural number. Therefore, the given number is a natural number. Therefore, root 49 plus root 4 by root 9 is 3, which is clearly a natural number, belongs to the set of natural numbers, capital N. The next set of numbers in the branch of mathematics is the whole numbers, continued from the set of natural numbers. So what are whole numbers? So let's discuss about whole numbers in this session. Whole numbers are the numbers which start from 0. It's very simple because every natural number along with a 0 is a whole number. Say for example, I have my natural numbers revisited to be 1, 2, 3, 4, 5, 6, etc. up to infinity is what we have discussed in the previous session. Then whole numbers is nothing but natural numbers, and including 0 is what we identify the difference between natural numbers and whole numbers. So with this we understand that the set of whole numbers is 0, 1, 2, 3, 4, 5, with the only additional difference being 0 between the natural numbers and the whole numbers. 0 along with a natural number is a whole number, is how we identify through the words. Zero along with natural numbers is a set of whole numbers, and this is denoted always by capital W. 0 along with natural numbers is a set of whole numbers denoted by capital W. Let's do some example problems to understand the concept of whole numbers more better.